Welcome to Unit 2, Lesson 6, Equivalent Equations. Our learning goal today is to investigate what makes two equations equivalent. We have 3 learning targets today. As we work through the practice problems, please keep these learning targets in mind. If at the end of class you are uncomfortable making any of these statements, please ask questions so I can clarify any misconceptions you have so you are prepared to succeed moving forward. The first learning target, I can tell whether two expressions are equivalent and explain why or why not. Learning target number 2, I know and can identify the moves that can be made to transform an equation into an equivalent one. And learning target number 3, I understand what it means for two equations to be equivalent and how equivalent equations can be used to describe the same situation in different ways. We have one glossary term for this lesson, and that is equivalent equations. These are equations that have the exact same solutions. That makes them equivalent equations. As we begin the practice problems for Lesson 6, the first problem states which equation is equivalent to the equation 6x plus 9 equals 12. An equation is stating that the left side is the same as the right side. In order for an equation to be equivalent, you would need to do the same thing to both sides of the equation so that it remained equivalent. This would cause it to have the same solutions. So as we begin looking at choice A, we have x plus 9 equals 6. To go from 6x to x, they divided 6x by 6. To go from 9 to 9, they did nothing. And to go from 12 to 6, they divided by 2. They did 3 different things to each part of this equation. So this is not equivalent. Now we can look at choice B. To go from 6x to 2x, they divided by 3. To go from 9 to 3, they divided by 3. And to go from 12 to 4, they divided by 3. Here they did the exact same thing, dividing by 3 to each part of the equation to get the new equation. So B is an equivalent equation. If you have any questions about how to identify equivalent equations, please ask for clarification now so you can be prepared moving forward. Our next practice problem says select all the equations that have the same solution as the equation 3x minus 12 equals 24. Notice that it says all, so we have to check every possibility because there can be more than one correct answer. So for choice A, to go from 3x to 15x, they multiplied by 5. To go from negative 12 to negative 60, they multiplied by 5. And to go from 24 to 120, they multiplied by 5. They did the same thing, multiplying by 5, to each part of the equation, so A is an equivalent equation. Now we look at choice B. To go from 3x to 3x, they did nothing. Now we only have 12 on the right side. To get 12 on the right side, we would have had to subtract 12 from 24, but if we subtract 12 on the right side, we would have to subtract 12 on the left side, and that would give us negative 24. So they added 12 to the left, but subtracted 12 from the right. So they did opposite things to each side. In order for this to be equivalent, you would have had to do the same thing to both sides. So B is not a correct answer. Choice C. To go from 3x to 3x, they did nothing. So that is still the same. To get rid of the negative 12 on the left, they added 12. To go from 24 to 36, they also added 12 to the right side. Because they did the same thing on the left side and the right side, these equations are equivalent. So C is an equivalent equation. Choice D. To go from 3x to x, they divided by 3. To go from negative 12 to negative 4, they divided by 3. And to go from 24 to 8, they divided by 3. They did the same thing, dividing by 3 to every part of the equation. So this is an equivalent equation. Choice E. To go from 3x to 12x, they multiplied by 4. To go from negative 12 to negative 12, they did nothing. And to go from 24 to 24, they did nothing. This is not an equivalent equation. They made one part of the left side 4 times larger, but they left the other part of the left side the same, and they left the right side the same. So E is not a correct answer. If you have any questions about this practice problem, please use class time to ask for further clarification so that you are prepared as we move forward. Our third practice problem says Jada has a coin jar containing N nickels and D dimes worth a total of $3.65. The equation 0.05 times N plus 0.1 times D equals 3.65. This is one way to represent this situation. Which equation is equivalent to the equation 0.05 times N plus 0.1 times D equals 3.65? So this time we're looking for one correct answer, so we will check each one until we find the correct one. When we look at choice A, to go from 0.05n to 5n, they multiplied by 100. To go from 0.1d to d, they multiplied by 10. And to go from 3.65 to 365, they multiplied by 100. So here we see they multiplied two parts of the equation by 100, but one part of the equation by 10, so this is not an equivalent equation. Choice B. To go from 0.05n to 0.5n, they multiplied by 10. To go from 0.1d to d, they multiplied by 10. And to go from 3.65 to 365, they multiplied by 100. So they multiplied two parts of the equation by 10, but a third part of the equation by 100. This is not an equivalent equation. Choice C. To go from 0.05n to 5n, you multiply by 100. To go from 0.1d to 10d, they multiplied by 100. And finally, to go from 3.65 to 365, they also multiplied by 100. Because they multiplied every part of the equation by the same amount, this is an equivalent equation. So C is the correct answer. If you have any questions about how to solve this practice problem, please use class time to ask for further clarification so that you are prepared as we move forward. Our final practice problem for Lesson 6, select all the equations that have the same solution as 2x minus 5 equals 15. So we have to check every answer because there can be more than one correct solution. Looking at choice A, the 2x didn't change. They got rid of the negative 5 on the left by adding 5. they went from 15 to 10 by subtracting 5 on the right side. So A is not a correct choice. Now we look at B. The 2x is the same. So we look at -5 goes away by adding 5 to the left side again. $15 becomes 20 by also adding 5 to the right side. Because they did the same thing to both sides, this is an equivalent equation. Now we look at choice C. Here we can see that they divided 2x by 2 to pull it outside the parentheses, but then they still left the -5 the same. So if we actually distributed this, 2 times x becomes 2x, 2 times -5 becomes -10. -10 does not equal -5, so this is not an equivalent equation. Now we look at D. To go from -5 to -20, we subtract 15 from the left side. To go from 15 to 0, we subtract 15 from the right side. Because they did the same thing to the left side and the right side, this is an equivalent equation. Choice E. To go from 2x to 4x, you multiply by 2. To go from -5 to -10, you multiply by 2. And to go from 15 to 30, you multiply by 2. Multiplied each part by 2, and since they did the same thing to each part, E is an equivalent equation. And finally, choice F. we now have a -2 instead of 2. So they multiplied by -1. We now have a +5 instead of a -5 because they multiplied by -1. And then we still have a +15. So they multiplied the left side by -1, but the right side by +1. So because they did different things to each side, this is not an equivalent equation. If you have any questions about anything we covered in Lesson 6, please use class time to ask for further clarification so that you are prepared for success as we move to the next lesson.